USB 3.0.
Yeah, same. Yep. Got a little bit of time before we get started. Everything is slow.
Sync now for 5 minutes or something.
Yeah, we'll see. So the official start time is 20 after, right? Okay. Does anybody have a full copy of the image yet? I know we've got one. Some guys were in here earlier. Some people don't know what I'm talking about yet, and that's okay. We'll get them.
I also before, but I didn't see it. So.
So we're going to get started in a little bit here. I'm still trying to copy images around. I have an atomic image to use that has Kubernetes installed. And I've left some time at the beginning to help pass this image around while I describe what we're going to do. But wireless isn't going very well. So I've created my own wireless network, which is equally not going as well. So here's one for you. So for those of you that don't get an image up, best case scenario, this will be a demo for you. I'll be going through all the demos themselves on this machine up here, so you'll at least see what to do. It is fairly straightforward.
Mike, if we just install, like, if we've got a Fedora host OS, can we just install Kubernetes and just use it from our host OS?
Yes, if you have Fedora, you can yum install Kubernetes. You'll need to start the Kubernetes services. So if you use syscontrol to look at the Kubernetes processes and etcd, I guess I can tell you which ones to start. But yeah, all this stuff should work just as well there. you go. Did you have one too? Okay. So I know we've got a couple of images on USB keys that are going around. Please do send those around as you're able. We'll go over exactly the install steps in a bit. Those of you that are downloading the image, just let that run for now, and we'll see how long it actually takes. I think this one will probably be my last one I'll be able to do. I think I gotta get started. What's that? Yeah, we have to get from one or the other. Okay, so I've got to get started. Finish where they started. And just a reminder, if you are running Fedora, you should be able to yum install Kubernetes and then turn on etcd and any of the Kubernetes services that were installed. If you know how to do that. When we get to that part, I can do a show of hands and see who's stuck on it. You won't need to edit any configs for what we're doing today. Okay. So the image that I am passing around, and I guess I can put this up on production, but you don't really need to worry about it, or for download. Just don't use this in production anywhere. Everybody's got the same passwords and stuff, and I tried to disable password logins via SSH and all this other stuff, but just don't even bother. Just so the image you're using is just for this workshop. It's an atomic image that I've created that doesn't require cloud in it or anything, so there's passwords and stuff that are set in there. You don't even have to worry too much about it. So just a quick show of hands. Who here has used Docker and is familiar enough that they've actually, spun up a Docker image of some kind? Okay, so I'll touch on some of the Docker bits as well. What Kubernetes is an orchestration piece that's supposed to work across several nodes, and basically you describe to Kubernetes what you want to do, and it goes out and does it, and it creates these images and applications and does all the work that's required for you. And so one way to think of it as a Docker wrapper, but that exists across several applications. And I've got this last image here to go over, and we'll look at it. But the username and password for, I think, the both of you that have an image is CentOS and DevConf 2015. So this. Okay. So we'll go through this. So it's a QCOW2 image, and just real quick, so I know who has it. Who has the QCOW that they can use right now? We've got 1, 2, 3, 4, 5, 6. Okay. So I'm going to be using libvirt for this, and I guess for the rest of you can just follow along. I'm going to create a new virtual machine, import from existing image. I'm going to browse to our new QCow. So this is the file name of it, if you've got it unzipped. It's a virtual machine image that contains CentOS and the atomic version of CentOS. So forward and finish. So this is a terminal. My resizing abilities in a virtual machine terminal are limited, but is this viewable at least by people in the back? You kind of see what's going on? Okay, good. So again, the login is CentOS, and the password is devconf 2015. Okay, so has everybody who has an image been able to log into it? Anybody not been able to log into it? Okay, so the first thing we're going to look at is the actual Kubernetes binaries and configs. And you can do this by rpm-ql Kubernetes, and you can look at the configs in /etc Kubernetes, and we're going to do that here. This isn't some gigantic package of files that get slown all over your system. There's really not that many of them. And so at the very top you can see we have the config files, API server config, controller manager, kubelet, proxy, and the scheduler. We have several binaries. The one to really take note of is kubectl. That's the one we're going to be interacting with. That is the command line tool for Kubernetes. You've got your systemd unit files to start the services, and then the rest of it is documentation. And so there's really not a lot to Kubernetes. In the example that we're doing today, all of the nodes and the controller, everything is just on one machine. Typically what you would have is a central Kubernetes master, and then you'd have several Kubernetes minions, or really they're called nodes now. And so what you would do is take your, you install different services on each. Kubelet is, for example, one of the services that goes on your nodes where your customer applications live. But the API server is one that would go on the master. But again, in the demo today, we're just having it all on one machine. And so you need to have, for those of you that have just quick show of hands, who is trying this on their local machine without the QCow, with just Kubernetes installed on Fedora or something? Okay, so the processes you need to make sure are running are the Kube API server, Kube controller manager, Kube scheduler, Kube proxy, and kubelet, and then also etcd.
So when I tried to start Kubelet, it was telling me there was no Docker orders. That's something.
What's that?
When I tried to start Kubelet, that was the only one that wouldn't start.
What did it say? I guess you've got to have Docker installed and running too. Make sure that is.
If Docker IO is installed, but is there supposed to be another package that has Docker-IO?
I think they've renamed it. You're in Fedora 21?
Yeah.
I think it's just called Docker now. The one I've got, this is a CentOS machine, and it's got Docker 313 on it.
Yeah, it's if you do a yum install Docker, it's Docker-IO. It's the same thing.
Okay.
And there's a service for that too that I also started.
Okay. And it still won't start the kubelet?
Yeah.
Okay. I have to look at that another time. All right, so we will continue. Next thing you do is, once all that stuff is running, is to list your minions and pods. And for those of you that aren't that familiar with Docker, I've got a slide, I think it's two things away, that I'm going to kind of show you what the Docker equivalent is of all this stuff, and then show you how Kubernetes does it. So for those of you that came to my talk yesterday on Kubernetes, I talked about pods and minions and some of these primitives. The pod is sort of a collection of compute resources, and it could contain a couple of containers. And so an example of this might be, it's kind of frustrating. Oh, we've got this container. Why do they need to have pods too? But if you think about something like maybe a JBoss system that needs memcached or Apache needs memcached, you could have each of those in their own containers, but as part of a pod. And that pod is what gets replicated to the different nodes as you say, say you need 5 of them or 10 of them. That pod as a complete unit gets copied, and that way you don't end up with, some of them may have the memcache, some of them may have Apache, and they need to talk to each other. You have a defined set there. Whereas an entire application would typically consist of several pods. Maybe you have a database layer, an application layer, and a caching layer. Each of those would have several pods in them. So to go through and look at our kube control commands, we're going to get pods and get minions. And we'll see that there's nothing in there. It's not a very interesting view.
What was the patch again?
DevConf 2015. So if you get pods and get minions, there's nothing really listed there. The minions shows localhost, which is normal, but typically you'd see a whole list of your virtual machines. There, we just have the one. So this is just a really quick check to make sure things are mostly working. And so the next thing is to double check what we're using here, so you can cat Red Hat release, and we'll do that. Go to my terminal. So I've got Linux CentOS. I made this particular image for DevConf 15, and just a reminder, don't use this in production, for goodness sake. So next is a quick Docker refresher. We're going to look at the images, and this is one of the reasons I had put this image together was the internet's been kind of flaky, and so when you go through and do this your first time, which the guys that have installed Kubernetes manually are going to do, the example that we're giving has a basic Fedora Apache image, and Docker will go out and download this off the internet for you. I have pre-cached that image, which makes it a lot easier to run. And so we're going to run these 2 commands and show you what it looks like. So, you can see that there's some built-in Kubernetes images that are out there, as well as the Fedora Apache image. And so if we want to, we can actually create this image with So what this command is doing, it will do as soon as I specify it, is call upon Docker run. The --rm command tells it to remove the instantiated container after we're done with it. Basically, just like a process can be on and off. Docker images can be on and off as well. And so you can kind of think of an image as an RPM that's installable and all this stuff. But once it's running, you've got some sort of binary that's actually running in your process space. And by default, Docker will not remove that unless you tell it to. And so in this case, I'm telling you, I'm just going to run bash, I'm going to do a couple things, and as soon as I exit, Docker's going to remove that information. The -it is basically, I'm just telling it to go into an interactive terminal, and we're going to run the Fedora Apache image, which, as I mentioned earlier, if I had not already downloaded it, would go out to the Docker registry and download it for me. And I'm going to run bash, so I'll run this command now. A lot of this is debug information because I'm using TTY1, so this is some of the dmessage stuff that comes up. But you can see that my prompt has changed, right? Before it was the CentOS at whatever IP. And now I've entered the Docker container. I'm now root inside my Docker container ID. And if you remember from the one of the earlier steps that we'd made, we were running CentOS on the host system. But on this one, I'm running Fedora 20. And so they're sharing kernel. This is not virtualization, but this is how containers work. I'm now contained inside of my container. It is running Fedora, has Fedora user space libraries, but it's on a CentOS host, and so I'm contained in here. Or if you ask Dan Walsh, I'm not contained, but I'm contained enough. So, let's see here. Yep. And so now I'm just going to exit out of the container and go back into the normal shell. Yes, and so you kind of think of it as your pool of compute, and you tell Kubernetes, I want these images out there, and it will do its best to figure out how to do that. We're going to see in an example later that it's not magic. It'll fail if you don't do it right. So the next thing we're going to do is create our. Oh, go ahead.
If you want to add other machines, you want to connect to the network. Is there a protocol that Kubernetes protocol that handles the communication, or it just uses the generated protocol?
So there's a protocol that goes in between them. You basically have to list them out in a config right now. It's a comma separated line that you have to do. Kubernetes is only about 8 months old, so there's still a lot of things that at least I would expect there to be there that are not, and I kind of have to remind myself it's still a very young package at this point. But even with that, it's still pretty useful. So, okay, so we're going to create our first Apache pod, and these are the commands we're going to run. And for those of you following along, you can just do them. But I've got an Apache JSON. I guess this would be something that'd be difficult to do from the RPM installed. Basically, what we're saying is we're going to define a pod with the Apache name. Apache is the ID. You can give it a version. And really, the important parts here that you're going to call it Apache. It's a pod. The inside container is going to be port 80, and I'm going to expose that port to the outside container on port 80. And the image name is Fedora Apache. You'll remember that from the Docker command that I had run earlier. And just remember that there's a registry out there that has a bunch of Fedora images, a bunch of all kinds of images, and this is just what that one is called, Fedora/Apache. And so to call it, I just run kubectl create -f Apache, and that's the command I run for any of the types, primitive types I'm going to create for Kubernetes. It could be a pod or a service or a replication set. We'll go over all of those. So
Where should the JSON file be? In the home?
it's in the CentOS home, yeah.
I don't have it. It's in root home first.
You check root's home directory then. It's not in your CentOS home? It's surprising to me. What's that? You should be able to sudo. Yeah. Okay, so let's take another look at our pods. This is a command we had run earlier, and it was empty, but this time it's working. It's stuck in waiting, but it's mostly going. We can see there's a Kubernetes. Oh, hang on. So right now it's hanging up, and I'll tell you why. It's because I'm connected to my Kubernetes network. So for those of you that did not get the download, I'm sorry, you're not going to be able to get the download because I've got to go back here. Basically, what Docker is trying to do right now is go out to the Docker image repository and make sure that it has the latest version of that Fedora image that I'm downloading. And it can't do that on my Kubernetes network. So I'm going to rejoin to the Brno network, and hopefully I'll get back online and see how that goes.
Is there a way to download these sample JSON files from the Brno?
So there, let me do this. The example that I'm running actually came directly off of the Red Hat developer blog, which is a pretty easy. No, this is an older one. There we go. Testing Kubernetes on time and cost. Yes. So I'm going to make a bitly of this, so you guys can do this if you want. So this bitly right here, if you want the actual JSON files and examples, bit.ly/1 UN9VCB, and I'll write this up here so I can move on. It's on the board up here. So you can always do that in your leisure or tonight when you get back to your hotel. Okay. No problem.
Could you show the command again to start?
Yes. And make sure that you are back on the regular Wi-Fi for that if you had joined the Kubernetes network, because it will not work.
And again, how to build the code from this JSON.
This right here has, if you go to this URL, it has the JSON files in it. And try recreating that pod. Reboot my system real quick just to make sure it picks up the new DNS entries. Yes. Can you speak a little louder? I can't hear you.
Yes, I was able to create a pod, and it tells me that the connection refused to 80. Did I stop the Kubernetes? What should I stop? Kubernetes daemon or?
So you're not running off the image. You installed Kubernetes manually,
Yes.
and all the services are started and running,
Yes.
and etcd is also running. You might need to, once etcd is running, you might need to restart the Kubernetes services again.
It tells me that there's no such a service as Kubernetes. I have installed Kubernetes, so
There's like 4 or 5 services. You can do an rpm-ql Kubernetes, and every single one of those service files needs to be started. Mhm. It's normally get a lot of them.
So how do we know that the pod is started?
You'll see it in 2 places. One, it'll be in Docker PS, which mine isn't yet. And the other one is kubectl get minions. Or not minions, sorry, pods.
I get it.
And it should be in...
Pending.
So pending is fine. It means it's probably, it means it's still out and setting things up. And it can take a little while. How long has it been running? Well, it should be done by now, but check... Oh, I know what I did. Okay. I'll try this again. Sorry, I had this all set up for the download setup, and it needs internet access. So,
So what's the next step? Like I created the
So what you should be seeing, and what mine is up to right now, is that you've got 2 Docker containers that should be running. One of them is, the top one is the Apache latest. The next one is you can think of it as a meta cartridge, or a meta container from Google. And so the top command was a Docker command, and it's showing that the compressor up and starting to run, and the Kubernetes command shows mine status waiting, which it should come out of status waiting pretty quickly here.
All those containers should be present right after we do kubectl create.
Mm-hmm. Yes. Now, yours will probably take longer than most because it has to go out and download those packages because you didn't do it on the image has them pre-cached. So has anybody else gotten basically what I've gotten where kube control's running and their Docker containers are running? I've got at least 1, 2.
So if you don't have a container,
What's that? So impending means that it's probably going out through the university network right now and downloading that image, and it's. Well, yeah. If you don't have any network, it'll be pending for a while. So.
but we'll work on it for a while.
It should, yeah. And so for those of you that have gotten started, all I can do is I apologize and say that if you're going to use Kubernetes in your production environment, make sure that you're not hosting the conference at the time. So we'll go with that. Yeah, and so do you have run Apache? Is that running? So another way to check it is we did specify that this should be exposed, and so you can go to our next file here, which is to actually confirm that it's working. So you can do a curl against 127.0.0.1, or you can browse to your virtual machine IP, which for me is 122.75.
So when we create a pod, it first downloads the image, and then it creates the container.
Yeah, and that image has the container image in it, and it will start it. And so in my case, I've got Apache up and running.
Because I have made this kubectl create already a couple, I don't know, 2-3 minutes ago.
When you do get pods, what does it show? Kube control get pods. Okay, so the next thing I'm going to do is delete the Apache pod. Is there anything listed? Okay, so it did not actually submit that. So you probably have you want to check the Kubernetes logs and see if they have any tips as to what's not running. So I'm going to delete the Apache pods at this point, and I'm going to create a service and kind of go over what that all looks like. And can I do a quick time check? How much do I have left? Okay.
The weird thing is when I do kubectl create minus Apache JSON, it tells me that Fedora Apache already exists.
That's probably if it's downloaded, that's fine then. It downloads the image and it caches it locally, similar to how Yum Cache works. Okay, so from here, I'm going to basically delete this pod. And I guess before I move on, does anybody have any question about what happened there in terms of what is actually running? I've got Kubernetes went out to my node and created a pod. And inside of that pod, I guess I can show this with my mouse. Inside of this Kubernetes Apache pod is running a container, also called Apache, and the run Apache command, which is actually just an HTTPD. And just to even further kind of demonstrate this, what is going on and how this is different from virtualization, and for those of you who haven't used Docker before, inside of that container I can actually attach if you do tab complete, it goes quick. You really only need this much of it, though. So now I'm actually inside of my container. You can see I'm root at Apache, and just like before, inside the container I'm running Fedora 20. And if I do a PS, there's not too much running at this point. You'll notice that there's no init showing up. Systemd is not running inside my container. All I have is the HTTPD that's running. The Apache control command that actually starts it, that's the thing that starts as root, And then, of course, PS, which I just ran, and the bash container, or the bash that I have attached to run into, so that, the actual bash process that I'm running right now. That's the only thing running inside of the container. But if I go back to the host, you can see that I have all the normal stuff that should be running in a virtual machine, but also you see the things that are running inside of my container. So as an operator or systems administrator, one of the things that's really handy about this is that if a developer or something does create an image and hands it to me and I run it, it's not like he's set some sort of weird root password in it or any kind of other weird stuff that's going on. I still have full access to this container that he's given me. I can get into it. I can do whatever I want to with it at any time. Even from the host operating system, I can see what processes are running. I can attach to those processes. For example, I could run strace on these things if I want. And so when they say, when they're talking about containers, they're talking about just that individual application running inside of the container. This is really what they're talking about. Inside the container, I have this namespace process and namespace file system. Everything inside of there looks like it kind of looks like a dedicated virtual machine when you're inside of it. From the outside, though, I can have the full view into it. It shows up in my process list. I can attach to it. I can attach to it without having to know what root password there is in there because that Docker image belongs to the system, and so it belongs to me, even though it's given to someone. So that's really what's going on. So to get back to the example here, I'm going to delete this pod now because now we're going to go into services, and I'm going to talk about how Kubernetes sets up environment variables inside of the pods for use. Okay. I'm going to leave this up here for a second for those that are typing along. You want to do it. This first command, the kube control delete pods Apache. If you remember, the name of the pod from the JSON file was Apache. That's what this is. It's called Apache. So we're going to delete the pod. At that point, Kubernetes will go out and delete its knowledge of the pod, but then it'll also remove it from Docker, right? And so when we do the Docker PS, it'll show that there's no more processes running. That can take a few seconds. But it'll happen, and then we're going to go back to the website that we viewed earlier, and I did this very quickly, so I'm going to do it again. The Apache web server that's up and running, it just has a simple response that just is Apache, and if I go to something else, I think it'd probably give me a 404 or something, yeah. It's a very basic system that is running there. Okay, so let's delete the pod and go from there. So let's go into how these things are named. So the name of the image that I downloaded from the website was called Fedora/Apache. And so if you do a Google search for the Docker registry, there's some umpteen million images out there, of which one of them is Fedora/Apache. And the colon there, by the way, is is the version number. So you could put an actual version in there, or you could tell it to do the latest, and it's actually got to go out to the internet to get it, which is why it was failing for me earlier. It couldn't get out to the internet to confirm that it's the latest. So the Docker image itself, yes, that is called Fedora Apache. But if you look in the JSON file that was listed, Kubernetes thinks it's called Apache because I've just called it Apache. I could call it, I could call it Cupcake or something else if I wanted to. But for this particular application, and there could be hundreds of applications, I've just called it Apache. So I could have. Yeah.
If you copied and pasted the JSON file from the website.
Oh yeah. Yeah. Okay. It's a little bit different from the website then. Okay. Yeah. Okay, so we're going to delete this pod and start with services. So, and Kubernetes has really great bash completion. So you can tab complete pods. I can tab complete anything else that's running. I'm going to run it, and so it'll wait a little bit. And basically, it's just responded with Apache. But what we'll see is if I do a get pods, it's not showing up. And Docker PS, they're not showing up there anymore either. So it's pretty quick. I mean, it just took a few seconds to go through and terminate all that stuff. And so I can go through and refresh. I should get a connection denied error now. And so basically all we've done at this point, once Kubernetes was running, is we've created the pod. It in turn created a container. and then we've deleted it. So it was very straightforward. There was really not much to it there.
So how much of it contains just to run after we both?
It can take seconds. Let it go. How long? You guys are running the image. Do you have internet access right now? Is it working? Well, let it do it. What's in your varlog messages? This does happen quite a bit, though. By the way, I'm just reiterating. Kubernetes is very new, and not only that, but we're running a very old version of Kubernetes in this image. So sorry about that. This was from late November. Continue for a little bit. Let it run, see what it does, and if I'll come back and take a look in a second. Okay, so the next thing we're going to do is create a service. So a service is how, when you define a pod, and a pod is really just compute of some kind. You can kind of define what ports to export and all this other stuff, but a service is how Kubernetes defines what's going to be attached to that service. And so basically a service, you can think of a service as a load balancer that then points to these back-end services, and it shares the Apache pod services running. So in this example, it's very straightforward. There's just going to be one Apache pod, and we're going to have an Apache service in front of it. But you can imagine that you might have, a MySQL cluster that would have 3 MySQL servers in the back. This service is is what your Apache front end would use to contact those back end services and try it out. So we're going to look at the service. I'm going to create the service first with the kubectl create command. Then I'm going to create the pod. This is the same pod we had used earlier. I'm going to show the pods are running, show what Docker's running, and we're going to basically show the same thing again, and then we'll go into some of the new stuff that has happened because we've chosen to use a service. So. Okay, so the service files are very simple by default. So this service is also going to be called Apache. You can see that it is of the kind service. The other one was kind pod. And just like before, we've got to map what ports we're using here. So we've got port 80 is the external port. The container port is port 80, and it's called Apache. We're labeling it as Apache. So.
Is it possible to configure this a little bit?
To what?
Make it bigger?
It's in a terminal. I don't know how to. I mean. What was the question? It should be in the same directory that Apache is in. Really? I literally just copied this thing. I hope I didn't give you guys a bad image or something. All right. Okay, well, sorry guys. I will continue and hopefully we can... Oh, so, go here. The Apache service file is listed at this bit.ly address. You can copy and paste it in there if you have. What's that? Yeah, it's bit.ly/1UN9 capital V capital C capital B. So I'm going to take a look at your image real quick.